something that we just spoke about, and I had said this when we were over there talking on that sideboard, where we had that negative variable, or it looks like a negative variable. There are two ways to look at that. One, yes, negative b. But the other way, and this is going to be important for us when we talk about this lesson, is that you could also refer to that as the opposite of whatever that variable is. Right? For instance, if you look here at the top of your notes, when we see the negative sign in front of a 5, most of us just instinctively call that negative 5, and I'm not asking you to change that, because that's what it is. But an alternate definition, or an alternate way to think of it, that's just the same as saying the opposite of 5 also. Negative 5 is the opposite of 5. So you could view it both ways. And you're probably wondering why I'm asking you this or telling you this. Well, it's going to help us as we develop our rules for multiplying integers today. Now think back to when you first learned how to multiply. What was it? Third grade, second, third grade? Sixth grade? When was it? Some of us are hoping to learn how to multiply right now, like figure it out. But whenever you learn, your teacher didn't probably instruct you, at least initially, how to do it, or they probably instructed you how to do it using addition instead of multiplication. Because multiplication is just essentially paired addition as we do it, because you already knew how to add. So that's what I'm going to look at here, and I'm going to break it down to the simple elements. So in this table, the very first problem is 3 times 2. It is 6. Good job. We got that, right. Unfortunately, it gets a little trickier throughout here. But let's talk about this. When I mentioned how we did this as addition, how could you write 3 times 2 as an addition sentence? JC? Negative 2 plus negative 2. I was going to go with it and see if it can. 3 plus 3, she changed it to. You were just jumping ahead, right? 3 plus 3, or what? Other ways. Sarah? Or 2 plus 2 plus 2. It's either 2 groups of 3 or 3 groups of 2. Multiplication is commutative, so you could reverse, and we've already established that, yes, that is positive 6. All right. Now, 3 times a negative 2. JC. Yeah, there's your negative 2, negative 2, negative 2. It's 3 groups of negative 2. That's the equivalent of 3 times negative 2, which would lead to a sum of what, Ellie? You could. That would be more for this next one, because you see how this is already in the negative. So Ellie just kind of gave us our next one here. Negative 3 times 2 is 2 groups of negative 3, which would equal negative 6 there. All right? Now, it's this last one that we're using this concept here. Because when you have 2 negatives, I can't have negative groups of numbers. I can't have negative sets of numbers. So we have to look at it more like the opposite of. So we would treat this problem here as like saying the opposite of 3 groups of negative 2, or the opposite of 2 groups of negative 3, if that makes any sense. So what I would do for this, I'm going to say the opposite of, and I'm just going to do 2 groups of negative 3 because it's less space. So I would do negative 3 plus negative 3. I put the whole the quantity negative 3 plus 3 in parentheses, put the negative outside of it to mean the opposite of that. So what would that all clean up to actually equal? Finn? It's 6. Because negative 3 plus negative 3 is, of course, negative 6, and then you take the opposite of that, you're going to end up with negative 6. All right? So you're looking at this, and hopefully you should be trying to determine some sort of pattern or trend or rule even that you could associate, that anytime I give you a problem that involves multiplying negatives, not necessarily the first one, you obviously know how to do that, but that is going to help us to establish a rule here. Can we think of something? Do we see a pattern going on within our table here? What do you see, Leah? She says a negative times a negative is a positive. It appears so, and she's right. Good. What else? Brady? So let me go back. Yeah, and you're right. So let me do negative times negative, that's my notation there, equals, Leah said a positive. Now, Brady, you said a negative times a positive equals negative. Well, maybe. There doesn't have to be. What about this last one? Positive times a negative. Isaac? It's going to be a negative as well. Multiplication is reciprocal, right? Obviously, don't make me write positive times positive equals positive. All right? You can write that if you'd like. You know, I'm not going to write that. So, what rule, method, when I multiply two integers? Hayden, what are you thinking? You could, yeah. So, but how would you, could you determine the sign of your answer, your product, prior to actually doing the calculations? That's what I want to get to first. But what you said was right. Jack? How? So you're looking for positive times a negative, or a negative times a positive. Yeah. That would be a negative also, but two negatives is going to give you a positive. Yeah. Okay, I agree. Mikey? So here I have 2, which is even, positive answer. Here I have 1. Here I have 1, negative on both. I like it. Finn? Okay. If there's, okay, yeah, I see, and that kind of supports what he was saying right there. Good. All right, so let's go down here. Before we actually write the rule, I did ask you, there was one number line problem. And I think it was, what was it, 2 times negative 4? Okay, so we could write it, just to be thorough here. How would I show 2 times negative 4 on a number line? You want to get a different chair? Move that to all the way to the back. And then just take one of those then. How am I going to show negative 2, or 2 times negative 4? Try it on your paper first. Like, try to graph it on yours. And And I don't mean that you have to use number lines when you're doing these, like from now on. I just wanted to show you an alternate approach to it. All right, number line, what are we doing? How are we doing it? Go ahead, Ellie. So you looked at it almost like, how would I write this as an addition problem? Two groups of -4, absolutely. Okay, good. But that also supports what you guys were saying earlier, because you said something like anytime you multiply a positive and a negative, you're going to get a negative, and we ended up with a -8 here, of course. Okay? All right, so let's get a rule. We're going to go by same sign, different sign. So meaning if I multiply, and the key here, guys, is we're talking about two integers, specifically on this particular rule. Anytime you have two integers, if they have the same sign, meaning both positive or both negative, you told me this already, we're going to get what? Sarah? Positive. So we're going to write positive product. Good. And we demonstrated that up above. So conversely, I have two numbers multiplied together that have different signs, and the order doesn't matter. Brendan, you're going to get a negative product. Exactly. Good. So let's apply that here. Just three basic multiplication problems. Calculate them out. How many of you are determining the sign before you ever even multiply? Any of you? Good. I think it's a great strategy. Then you don't have to mess with it. You got it figured out. Then you just look at absolute values. So, number one, what do you get? Product. We'll go quickly. Sarah? Yeah, -36. Positive, negative, different signs. Number two, Isaac? 20. Same sign. There's your positive product. Number three. Brady? 54. There you go. Good. Yes, sir. Yeah, sure. You just throw, yeah. So you're saying you just do like 3 times 12 and then throw the sign on after. Yeah, absolutely. Yep. Okay, let's turn this over. All right, try these 4 questions here. Give me the products for these 4 sequences, please. Take your time. It's easy to make a mistake on something like this. It looks simple, but I do see a lot of mistakes. When you get yours, check with your group. Make sure you agree with them, they agree with you. What do you think? I don't know. I'm hoping somebody's going to teach me how to do this. All right, so I put some answers on the board. I'm following the rule, at least I think I am, that we established on the front side where it says, hey, if they have the same sign, positive products. If they have different signs, we're going negative product. I look at every single one of these, same signs, all the way down. To me, that's a slam dunk, right? Just positives. I'm guessing by all the hands in the air that you disagree with me. All right? All right, I'm not right. But I need you to prove me wrong. Prove me wrong. Why is this not true? Go ahead, Leah. Bailey? Did any of you think the second one should have been -8? And she did it right. She did it 2 at a time. Okay. So now are we good? All good. Finn, what's wrong? Prove it to me. Why? Oop. So you counted them up and said, I have an odd number. I've got 5 of these things. All right. So here's something different, and I think, Mikey, you had brought this up earlier, right? Odd-even concepts here. All right. I don't know if any of you caught this, but you're looking at 2 numbers here, positive number. 3 numbers, negative. 4, positive, 5, negative. It is appearing like even numbers of numbers here produce a positive product, whereas an odd number produces a negative product. Yes, Sarah? Yeah, yeah, and it's kind of like that odd-even thing because you're looking at pairs, right? Which means evens, right? Good, Brady. So it goes back to negative then? Yeah. I see. So it's like a chain. Every other one just keeps changing the sign back and forth. Good. All right. So what if I did this? And you don't have to write this. Just look at it up on the board. What if I did -1 times -2 times -3 times 4? I have 4 integers. Based on what you just told me, right? 4 integers, positive. 4 integers positive. Is that right? So that means your rule doesn't work? I'm going back to Mikey. He said this earlier. Clarify for us, Mikey. Why is this still positive when I thought we said even number of integers is positive, odd numbers are negative? You're not counting the numbers, you're counting the negative numbers, right? Is that true? That's exactly true. I don't care how many numbers there are in a sequence. I can have 1,000 numbers in a sequence, and if one of them is negative and only one, it's negative. Okay? Likewise, I could have 1,000 numbers in a sequence, and if 998 of them are negative, my answer is positive. You're counting negatives. You're not counting total integers. So that's why our rule is this right here. And you can write this up. I try to do it in kind of an abbreviated format. Odd number of negatives, negative product. Even number of negatives, positive product. That only applies to a sequence of multiplication numbers. Don't try that with addition and subtraction. It doesn't work the same way. Unfortunately, when we start adding operations, we start combining rules, and then it's like, uh-oh, I got mixed up. This is only for multiplication. I guess, and division when you see that. So what we'll do tomorrow, we're going to pick up with the examples at the bottom, and then we'll do our division. And our division will take a third of the time that it took for multiplication because of the carryover from these rules. All right? So I'll see you tomorrow with that.